Hello, let us integrate the sine of the fourth root of x. And this function is a bit difficult to draw. As we see in the graph for this function here, this function isn't very high. Its maximum is at 1. But there isn't a whole lot happening until you go really far to the right. Because the first positive root for this function is at pi to the fourth, which is around 95. Apparently it's a little bit bigger than 95, as we can see in this function graph. But how do we integrate this? How do we integrate sine of the fourth root of x? And the idea will be to use my formula to integrate functions of the form f of square root of x, because what we are noticing is of course the fact that the fourth root of x is just the square root of the square root of x. So let us formally write down our process here. We will apply the formula for the integral of f of square root of x for the function f of x equals sine of square root of x. All we had to do to apply this formula was to always integrate the outer function f twice, which in this case means integrating sine of square root of x twice. Because in the formula there's this capital F and this capital G, and capital F is just an antiderivative for f, which is sine of square root of x in our case, and capital G is just an antiderivative for capital F. And we notice at first that if we set f of x equals sine of square root of x, then f of square root of x is the sine of the square root of the square root of x, and that is the sine of the fourth root of x. And so we can apply our formula. And we get that capital F of x is then just the integral of f of x dx, which is the integral of sine of square root of x. And integrating sine of square root is very easy. Again, if you use my formula, we have done this previously in the past, and so you can simply check a previous video to see this result. But we could even quickly do this in our head with my formula, right? All we have to do to integrate sine of square root of x is integrate the outer function sine twice. The integral of sine of x is just minus the cosine. And because of this, all you get here is a minus cosine, but then of square root of x, and you multiply by 2 square root of x. And then all you need to do is you need to integrate the minus cosine, which gives you a minus sine. And then you basically do this minus 2 times capital G, which then will change the minus sign to a plus 2 sign. And for the argument, you plug the square root of x, as is here. Basically, you can very easily apply this formula simply for f of x equals sine of x to get the integral of sine of square root of x. So yeah, that's very easy to do, and we've already seen this in the past. Now the uglier part is integrating the integral, right? Because at first you integrate sine of square root of x, and then you integrate the integral, right? You integrate capital F now, which is this large thing here. I mean, this isn't exactly a large term, but it will be large to integrate. We get that capital G of x is the integral of capital F of x, and that's now the integral of minus 2 square root of x times cosine square root of x plus 2 times sine of square root of x. So at first we use the fact that the integral is a linear function, more precisely an R linear function if the functions go from R to R, right? And so we just have to integrate. Basically, if we also plug this scalar out, we can do this. As I've said, the integral is R linear, which means that you can plug real numbers out of the integral. So this minus 2 inside the integral can be written outside of the integral and can then basically almost be ignored. The only real thing you have to do is integrate square root of x times cosine square root of x, and then you also have to integrate sine of square root of x again. Yeah, by ignoring the minus 2, I of course simply mean that we don't have to really integrate minus 2 square root of x times cosine square root of x, but we just have to integrate square root of x times cosine square root of x. And afterwards we can multiply by minus 2. That's all I meant. And so let us simply do that. And the square root of x times the cosine of square root of x would be a bit ugly to integrate, but we have made a video previously on where we integrated exactly that function. And we will simply use the result that we got from that video. We could again quickly integrate square root of x times cosine square root of x in our head by applying this formula here. By applying this formula here for the function x times cosine of x which you would have then to integrate twice, which is easy to do, but just takes some time. And after you get that, then you get the following result. The integral of square root of x times cosine square root of x is just 2x times sine square root of x plus 4 square root of x times cosine square root of x minus 4 sine of square root of x. Then you multiply this by minus 2 here, and then you just add plus 2 times the integral of sine of square root of x. But we've already integrated the sine of square root of x up here. You get this term here, and now you just have to multiply it by 2. And what you will get by doing this, yeah, I haven't done this yet. You just multiply this by 2. I've basically written all the formal steps here, you know, with this plus 2 and minus 2 still outside of here. And then you just multiply, and then this 2 here becomes a minus 4, this 4 becomes a minus 8, this minus 4 becomes an 8, and then this first integral term here basically will become a minus 4x sine of square root of x minus 8 square root of x times cosine square root of x plus 8 sine of square root of x, and then 2 times the integral of sine of square root of x. That will just be minus 4 square root of x cosine square root of x plus 4 times sine of square root of x. And so we're all already done. Now we have figured out capital F and capital G. Once you've figured out capital F and capital G, which basically means once you've integrated f twice, you can then just plug in my formula and you get the integral for f of square root of x. And so let us simply do exactly that. We plug in and we will get our solution. We will at first simplify this. This minus 8 square root of x and minus 4 square root of x times cosine square root of x terms can be added together to get minus 12 square root of x times cosine square root of x. And so finally, we can integrate the sine of the fourth root of x via the formula, and then we simply plug in. What we are doing is that we are putting our capital F here, but then we evaluate it at square root of x rather than at x. Here, this capital F of x, right? And this will mean that this square root of x will now become a fourth root of x, and the same thing happens to all the other square roots here. They become fourth roots, and you have to multiply by 2 square root of x here, which is exactly happening here. 2 square root of x times that, and then there comes a minus 2g of capital a minus 2 capital G of square root of x. So here is the minus 2, and then you just look at capital G of x and you plug in square root of x instead, right? So instead of having a minus 4x times sine square root of x, you now have a 4 square root of x times sine fourth root of x, right? And those other square roots here will become now fourth roots, right? And after you've done that, you can just multiply this out. Notice that square root times fourth root is basically the fourth root of x to the third, and also vice versa. It's basically the fourth root of x, and all of that to the third power, right? By all the power rules, you can basically write it as a fraction x to the 1/4, and that to the third is x to the 3/4, right? And hence you get this factor here with fourth root of x to the third, and then you just leave the cosine fourth square root of x, and then you have a square root of x times 2, right? So this just gives you another square root of x term. And on the right side, yeah, you simply multiply by minus 2, which is even easier. All those terms basically stay the same. The 4s become 8s and the 12s become 24s, and so we are basically done. The only thing left to do is again simplify this plus 4 square root of x and plus 8 square root of is to simplify by adding this plus 4 square root of x times sine fourth root of x plus 8 square root of x times sine fourth root of x, and you get a 12th square root of x times sine fourth root of x, right? Let us quickly turn off the graph for our function, and so we get our result. It's this huge thing here, and if we add all of this together, then we get that the integral of the sine of the fourth root of x is simply the last line that we get here, and that was minus 4 times the fourth root of x to the third times cosine of the fourth root of x plus 12 square root of x times sine fourth root of x plus 24 times the fourth root of x times cosine of the fourth root of x minus 24 times the sine of the fourth root of x. That's a very, very long term, and I could have never really guessed the solution for this without my strategy of just integrating the outer function twice. I mean, I could have done this with a substitution. You just substitute u equals fourth root of x. You can do that, but I simply am not a fan of the substitution technique. I always try to figure out a different way of integrating a function. And so I even did this here for this very complicated function, sine of fourth root of x. I just integrated this without a substitution. I basically just applied my formula and did the other integrals here in my head, basically, or by again applying this very formula for the integrals that are needed in the formula itself. If you understand what I mean. I mean, I applied the formula, but in the formula I got this capital F and capital G, and to figure out capital F and capital G, I used the formula again. It was basically a chained application of the formula, right? Which makes sense because the fourth root of x is just the square root of the square root. And then I apply the formula for the first square root, and then I apply it again. That's all I meant here. Hope I didn't express myself in a confusing way here. And so I guess the final thing that we can do is check our solution. The graph for the solution is here. It's almost impossible to draw this properly here. I just changed the axes around in a weird way. There we go. Now the axes are fine again. I guess we can change the axis. We basically don't really need any negative values, so let us try this instead. Now we are here. Let us actually make the y-axis much smaller. Okay, and then we will need to make the y-axis a bit higher. Let's make it at 50. Let us get rid of the texts that are on the way, because we've basically seen the solutions already. Yeah, these graphs for the functions are a bit ugly to draw because they stretch out so widely. Let us do it like this. Is this better? Okay, now it's a bit better. So you see the fourth root of x here, which goes to 0 here at around 95, and then our integral function. Actually, yeah, here we can get this integral sine of fourth root of x is this large term here, which has this function graph. And if we let this program here calculate the derivative for this huge thing here and draw it in magenta or purple, yeah, purple, I guess. We draw it in purple, and then the graph for that should overlap with sine of fourth root of x if we did it all correctly. And that's exactly what happens. We did it correctly. Can always check the solution at Wolfram Alpha 2 for confirmation if you don't have this program here available. This program is simply called graph, by the way. And yes, this verifies that we were correct. The program has taken the derivative of this huge term on the right side here for us and verified that we do get sine of fourth root of x. And this will be the end of this video, guys, and I hope to see you when we do the next integral.